Second page of problems on the geometry review. Number 7, this figure shown below is overhead deck view of a deck with a surrounding hot tub. What is the area of the deck? So the area of the shaded portion. We need to find the area of the larger circle, the area of the smaller circle, and subtract the two. So for the larger circle, this is where it gets a little tricky. The diameter of the larger circle is 4.2 plus 1.7. This bit would be 1.7 up here and 1.7. You'd have to do that twice for this part and this part. So you get a diameter of 7.6. Divided by 2 is a radius of 3.8. So 3.8 squared times 3.14, because they tell you just 3.14 for pi, is 45.34. For the smaller circle, half of 4.2 for the radius is 2.1. 2.1 squared times 3.14 is 13.85. So when you take 45.34 and subtract 13.85, you get 31.49. For the second problem, a square is inscribed in a circle that has a radius of 3, radical 2. Find the area of the square. So we need to find this length here, the side of the square. And since this is a square, this triangle is going to be a 45, 45, 90, because this circle here would be 360 degrees. There'd be 4 congruent of those central angles. So this angle here is now 90 degrees. So on a 45, 45, 90, we take the length of one of the legs, which is 3 radical 2, because these legs are congruent, and we multiply it by radical 2. So in this case, we have 3 radical 2 times radical 2, which give us 3 radical 4. And since the square root of 4 is 2, 3 radical 2 times radical 2 is 3 times radical 4, which is 3 times 2, which is 6. So this side length is 6. If this side length is 6, 6 squared for a square is 36. The area is 36. For number 9, we need to find the area of a regular octagon with side length of 9 centimeters. So I've drawn this triangle here. There would be 8 of these congruent triangles in a regular octagon. And this here is the vertex angle. That would be the side. So I'm going to draw an altitude. Now, first of all, to get this central angle, if I had 360 degrees and I divided it by 8, because there's 8 congruent triangles in an octagon, and we get 45. So this whole measure is 45 degrees. Half of 45 is 22.5. So I draw this angle bisector, which is also a perpendicular bisector. It's also an altitude, and these each get split into sections of 4.5. They're split in half. So now I'm going to use trigonometry to find this adjacent side. Since I have opposite and I'm finding adjacent, I'm using the tangent. And the tangent of 22.5 is going to be 4.5 divided by A, which is adjacent. 4.5 divided by 22.5 tangent in the calculator gives me 10.86 ... Because to take care of rounding issues, when I actually put that in, and I'm going to actually do it right now off camera, but 4.5 divided by, and you put 22.5 tangent, equals, you get 10.86396,103, blah, 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 blah. I'm going to leave that in the calculator. And rather than multiplying by the base and then dividing by 2, I could multiply this in the calculator by 9 and then divide by 2. I'm just going to multiply it by 4.5 times 4.5 equals 48.8878246 blah 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 blah. I'm going to take that number in the calculator, I'm going to multiply by 8, and that's how I get rounded to the nearest tenth is 391.1. When I'm rounding, I want to round as little as possible while I'm doing the problem. So if I have a number in the calculator that I can just leave it with a bunch of decimal places, that's the best way to do it. And that's how I get the answer for number 9 of 391.1. For number 10, find the area of a regular decagon. I've done that work over here. So it's a decagon. That means it has 10 sides. That means that the central angle is going to be 360 divided by 10 is 36. And when I draw this altitude slash angle bisector slash perpendicular bisector, it's going to leave two triangles, each with 18 degrees. They told me that I had the radius. That's the slant height. So I need to find the opposite side and the adjacent. Since I want to find opposite over hypotenuse, I use the sine of 18. And 18 sine times 7 in my calculator is the opposite side length, 2.16131. Now, to find the adjacent to the 18 degree angle, cosine of 18 equals adjacent over the hypotenuse. So in the calculator, 18 cosine times 7, I get 6.6574. Now, I'm going to find the area of this triangle. The opposite is 1/2 of the base. So rather than multiplying this by 2, multiplying by the height, and then dividing by 2 again, I can just multiply these together. 2.1631, because that's already half of the base, times 6.6574 is the height of the triangle. So 14.4 is the area of one triangle. Remember, it's a decagon. There's 10 congruent triangles, so a total of 144 units. This was actually centimeters. And for number 11, a regular hexagon has an apothem, that means the height of a triangle of 2, and the side length of 4 radical 3 over 3. So that would be that same thing here. That's the side length. So basically I'm doing 1/2 of apothem times side length. That's going to give me the area of one triangle. So I'm going to make this a little bit easier because 1/2 of 2 is 1, and 1 times 4 radical 3 over 3 is going to be 4 radical 3 over 3. I have 6 of those. That's what I've tried to write here. So 4 times 6 is 24 radical 3 over 3. 24 divided by 3 is 8. The answer is 8 radical 3. Some of you will say, but Mrs. Falk, how did you know you wanted it to leave it in radical form? The fact that the problem has simplest radical form in the measurements, in the dimensions, would be the key, that's how they expect you to leave it.